IPv6 was developed by the Internet Engineering Task Force, IETF, to address the impending issue of IPv4 address exhaustion and to replace its predecessor. The protocol uses 128-bit addresses, providing a vast number of available addresses that surpass the limitations of the 32-bit IPv4 system. IPv6 also introduces technical advantages beyond increased address space, such as hierarchical address allocation, simplified multicast addressing, and enhanced services delivery optimization. With the rapid expansion of the Internet since the 1990s, the necessity for more addresses became evident, leading to the establishment of IPv6. While IPv4 and IPv6 are incompatible for direct communication, transitional methods have been devised to facilitate the migration to IPv6. The new protocol streamlines address configuration, network renumbering, and router announcements, enhancing overall efficiency. The fixed size of the host identifier portion in an IPv6 address standardizes subnet sizes, allowing for unicast, anycast, and multicast transmissions. IPv6 multicast capabilities are fundamental and more advanced than in IPv4, eliminating the need for traditional IP broadcast addresses and simplifying packet delivery to multiple destinations. Stateless address auto-configuration enables devices to assign unique addresses automatically, with the option for routers to supply network prefixes. The design emphasizes end-to-end connectivity, promoting globally unique IP addresses accessible from any point on the network. Additionally, IPv6 routers enhance mobility and efficient routing, with minimized processing requirements for packet forwarding. The protocol mandates Internet Protocol Security, IPsec implementation, originally developed for IPv6 but widely deployed in IPv4 for security reasons. Unique to IPv6 is the elimination of header checksums, enabling end-to-end data integrity assurance through upper-layer protocols. IPv6 extension headers and jumbograms for larger payloads enhance performance and future protocol scalability. IPv6 packets consist of a fixed header and optional extensions with the flexibility to accommodate evolving network features without compromising the core packet structure. IPv6 addresses are represented as 8 groups of 4 hexadecimal digits each, separated by colons, offering a considerable advantage over the limited address space of IPv4. IPv6's multicast capabilities, simplified addressing methods, and enhanced security protocols contribute to the significant advancements this protocol brings to the realm of network communication and Internet connectivity. IPv6 addresses consist of 128 bits, a departure from the subnetting approach used in IPv4. In IPv6, a local area subnet always devotes 64 bits to the interface identifier for the host portion of the address, while allocating the most significant 64 bits for the routing prefix. Address representation involves dividing the 128-bit address into 8 groups of 16 bits each, denoted in 4 hexadecimal digit groups separated by colons. Address representation includes conventions for omitting leading zeros and condensing consecutive sections of zeros into double colons, provided this is done only once in an address. An example address is 2001 DB8 F0 42 8339. The loopback address is defined as POC-1. Link local addresses, indicated by the FE80 10 prefix, are crucial for all IPv6 hosts and entail a 64-bit interface identifier. IPv6 employs the Neighbor Discovery Protocol for address resolution, with hosts verifying address uniqueness by sending neighbor solicitation messages. Additionally, the protocol allows for stateless address auto-configuration and the generation of globally unique addresses via router advertisements. Dual-stack IP implementations are essential for enabling devices to engage in both IPv4 and IPv6 networks concurrently. The transition to IPv6 necessitates various mechanisms to facilitate communication between IPv6 and IPv4 networks, with tunneling emerging as a common approach. Various security considerations, such as shadow networks and IPv6 packet fragmentation, arise with the adoption of IPv6. The deployment of IPv6 commenced in the mid-2000s, with universities being early adopters and progress has since been made in various sectors, including Internet backbone transit networks and major ISPs globally.